Good evening, students. Let's wait for others to join and then we'll start the session. So yesterday I asked for a code. I guess still students are joining. Let's wait maybe for 2 more minutes and then we'll start. It's just 73. Let's wait for at least 100 and then we'll start. Maybe. Okay, I guess others are taking time. So let's not waste time of those who have joined. So yesterday I asked for Armstrong number. How many of you tried to do it? Armstrong number code. Armstrong can be a 3-digit number, 4-digit number. If it's 3, we take cube of the numbers. If it's 4, we take raised to the power 4 of the numbers, and the sum should be same. For example, 153, 371. These are all Armstrong numbers. So how many of you have done the assignment? Can I get some replies in the chat box? No one? Okay, no issues. Let's try to code together and see. I believe what is Armstrong number, that was explained very clearly. I got one chat. Srivalli. Okay, good. Srivalli says she has done. If any doubts are there related to Armstrong number, please you can ask. I guess the concept was very clear what is an Armstrong number. But still, if you have doubts, you can ask me. So now we'll first code that and then we'll go to today's session. Again, one important thing today from 8 till 8:15, we have a guest session of a speaker. So for that time, like I will request you all to be more attentive. So here we come. And on day 3 only, I guess we had Armstrong. Yeah, this is the one. See, there's an exclamation mark. There's pending here. It says that we have this just number. Fine. So here we have maybe we have a main method here. Int number is equal to 153. I'll take. And maybe I'll make a method only for this one and call that one. So I'll make a static method. This one will be my public. It can be accessed from anywhere. Static, I don't need to create an object. I can use it directly. Boolean, it will return either true or false. And is Armstrong is the variable I'm writing. It will take an argument. So I'm giving a parameter n. This n will be maybe this number. Okay. So now let's define the logic. Int original number would be my n. And this n here denotes to this n. So unless we don't give a Boolean return, this one will give us error because we have said that we are going to return a Boolean. If we write it void, we are not returning anything. So we'll return it, don't worry. Int sum, our sum would be 0 initially. And then while n is not equals to 0, means the number is not equals to 0 at that time. Yeah. Okay, Abdul has done it. Okay, fine. Gautam has done it. Good. Okay, we all have our different ways. Fine. So now I will do it with my way. And it's not necessary you need to do it this way only. You can have your own way. Digit is equals to number modulus 10. We divide it by 10, like module reminder of 10. So sum would be digit times digit times digit. Since we are taking 3 digits only and doing it hard coded, we are telling 3 digits. Oops. And then we are dividing it by 10. Oops. And then we need to return the sum, I guess. Is this original? Because original is n. So here we take it. And now let's put an if else statement here and see if is Armstrong. Since it's static, we can use it directly. Now, so then we can tell directly print num plus is Armstrong. If this is not the case, then you write is not Armstrong. So now for this code, I believe it's Armstrong number. If I run this, it should say it's Armstrong. But then if I put here 158, it should say is not Armstrong. If I put 370, it should say it's Armstrong. Again, if I said 371, again, this is also Armstrong. But then if I put 378, this is not Armstrong. Is this clear, students? First, you need to understand what is an Armstrong number. If you know the Armstrong number, then of course this all logic makes sense. If you don't know what is the Armstrong number, then we need to first target that. What is an Armstrong? Then we can go ahead. Okay, fine. So now we'll go with the day 4. Anyone any doubts in this? I believe this was an assignment, but most of you, I guess, did not do it or were not able to do. I don't know what was it. Again, this is my approach. There are some other approaches as well that are shared in the chat box. And no matter whatever your approach is, if you are able to explain it, of course, that is more than sufficient. You may use a for loop, you may use a while loop, you may use if else, you may not use if else. It's completely fine. There is no particular one correct answer for your DSA. You can have multiple approaches. We will see that today at a greater detail. So now we'll be going with the linear search. So my package would be day 4. Okay, fine. So maybe I need to make a package first here. New package day 4. And in this, we'll go with the linear search. We have linear search, binary search. First of all, how many of you know what is linear search and what is binary search? Because your divide and conquer, sorted data, they work on binary search and not linear search. How many of you know what is linear search, binary search? Linear search, binary search, divide and conquer work on binary. And you have sliding window. It is either fixed sliding or dynamic sliding. Like if you don't know, tell no, it's completely fine. We can go with the theory. Linear search means searching sequentially. Yeah, you traverse through each and every element. Sir, come on. Okay, how many of you know? I put it in the chat box. How many of you know what is linear search, what is binary search? It's there in the chat box. You can read it. If you are aware of the definitions, exactly, check one by one in linear search. Correct. Perfect. Okay, don't know search. Okay, fine. Abdul, fine. There are some students who are telling yes, some students who are telling no. See, when it comes to searching, okay, let me share something. You'll get an idea. Again, I'll share it with ma'am on email and she'll share it with you on the LMS as well. So, okay, fine. I believe yesterday's notes you all have got. Linear search will work on both sorted and unsorted data. Yes, because linear search you search one by one. In binary search, we need to sort and divide the array in half in each iteration. Yeah, of course. It reduces your time, Jatush, because your data is very big, but it's sorted. Okay, fine. So now here, let me DSA notes. And 1 minute. Which ones will they know? This one is different. Again, I'll share everything with you. I don't have to keep anything with me. DSA notes. Yeah, of course. Yeah, of course. Okay, fine. So now here you have, see, this is first, at least you all are know what is linked list, what is queue, what is array, what is stack, what is binary tree, graph. Are you aware of these concepts or you're not aware of these concepts also? Whatever you're seeing on the board, like the shared one. Okay, fine. Fine. If you're aware of it, then we'll go ahead with the next part. If you're not aware, fine. So data structures. Again, these notes will be shared with you. Not a big deal. Fine. Why is this? So basically here, if we come, time complexity, space complexity, all these things are there. Best average is O of n, O of 1, all these things are there. Big O notation, space complexity, input size, auxiliary space. So linear loop means you have O of 1. Again, we'll see this all concept today. More into details. So basically binary search and linear search are first. Let's come and see linear search. Okay, 2D arrays, and where is it? Linked list, no. Linked list and array list are different. Linked list is having address to just front and back pointer, and array list is having all the pointers. Circular linked list. 1 minute deletion. I'm trying to search something else. Yeah, of course, Abdul, I'll share these notes with you. No need to worry about it, dear. I guess ma'am will share it with you. I'm already sharing things with ma'am. So linear search, see, binary search is an efficient searching algorithm that checks each element of a list sequentially until the desired element is found. It works with both unsorted and sorted data. So basically what happens is, in linear search, again, binary search and linear search are different. So in linear search, what you do is you traverse. Traverse means you go through every element in your array. Arrays are zero index, hope you all know. So initialize, point to the first index of the array, point to the last index of the array. So this is your binary search step. So in linear search, you go through each and every element. So we'll do an example of linear search and then maybe a binary search. So basically linear search is you try to find, for example, there are 10 students. So I'll call all the students one by one, like roll number 1, roll number 2, roll number 3. I don't know what roll number like the students are. So I'll call all of them. So let's take an example of linear search. So you'll get an idea. Again, we will not be going to lead code or hacker rank or anything, but simple example we'll do here. So you get an idea. So now let's come here and yeah, you will get this notes, Abdul. Fine. So linear search. So basically, see what we'll do is we'll have an array, int array. We have an integer array, and this one would be 10, 23, 45, 70, 11, 15. So here you can see the data is unsorted. Fine. Our target is 70, for example. We want to find the target and we need to see at what index it is. Our target is 70 and we need to return index. So of course it's at which index? 0, 1, 2, 3. It is at 3 index. So we'll be using linear search here. Why? Because the data is first thing not very big, it's small. And again, it's not sorted. You use binary search on sorted data. Linear search is used on unsorted data. So you need to find out the number 70, that is your target. So maybe I'll put here in target also. I want you to return the index of this target, please. The index is 3, we know it. How will you write code for this? Yes, we can use sort function, array.sort directly, but I'll not be using sort function directly. I'll be using a for loop and iterating through it. If we don't get the target, we'll return -1 or else we'll return the number, target number. Please try to do it. You can do it in your way, okay? Free to choose any option of your choice. Just a small reminder, students, from today 8 to 8:15, our session will be at halt. We'll be having a guest speaker who will be addressing you for some important topics. So at that time, our session will be at halt. Yeah. So I give you maybe around 3 more minutes to find out the solution. If you are able to find the solution, well and fine. If not, we'll do it together. Okay, students? Okay, Piyush, the task is we have an array, you can see here. We need to find is 70 there in this array or not. If yes, we need to give the index of the array number. If you don't find it, you can give -1. Fine. Abdul has given the answer in one way. Yeah, you can use anything, Ritika. Arrays dot sort, compare operator, your choice. I am just concerned with the answer. Are you able to do it or not? If yes, show me the answer. If not, code with me. And again, I don't say that I am the best coder, but at least I can code it in a way wherein I can justify the answer as well. Because most of the time in DSA, they see your coding abilities. So let's try to find solution now together. So public static int linear, and then it will take an argument of integer array, fine, and it will search for the target as well. So for loop I'm using for traversing through the array, I is equals to 0, I is less than array dot length. So let it go till the end. I plus plus, we need to increment the value of I. And if array of I, if it is equals to target, then you return I. What does this mean is return the index of target. If this is not the scenario, then you return -1. Why -1? Because if target not found, return -1. Fine. So now here we have it. So here we come and we call that int. Since it's static, we can call it directly here. And maybe, okay, it's not returning, so I need to come here and yeah. So it was inside the loop, so it was having some errors here. You can see return was not there, I plus plus was not showing. The moment I move it outside the loop, the issues are fixed. So int result equals to linear. We're calling that function that's taking an array and target. So, oops. Let's use an if else statement and finish this code. If result is equals to -1, if you get this result, you tell element not found. Else, if you get the result, element, okay, found at index plus result. So currently we have hard coded our target 70. So it should return 3 if I have done the coding correctly. Element found at index 3. Now if I put it 11, it should tell element found at index 4. Oh, okay. It should be 11 years. Sorry. I did it in comments. It's not valid. Element found in index 4. But if I try to find something that is not available here, so it should say element not found. If I do 23, it should return element found at index 1. Is this clear, students? What happened behind the scenes? Any doubts, anyone? This is your entire code here, you can see. Yeah. Yesterday, there were some doubts regarding time complexity. Are you all having still some issues with time complexity? Yesterday, I explained one simple code. And today, if you have doubts, again, I can explain you one code with 3 approaches that we go with prime numbers. You will understand time complexity much better. Is time complexity still an issue, or time complexity is sorted? What is O of 1, O of n, O log n? Are there issues with time complexity, or it's sorted? See if you sorted. Okay, Jatush. What about others? Okay, Piyush, sure. What about others? Like, if I get some answers, I'll be also more confident. Yeah, I'll do with one more example, not an issue. Explain again, sure. Right. Okay, sure, Ansari. Okay, fine, fine. Let's do it. Okay, sure, sure, sure. Fine, okay, fine. So before we go with the code, do you all know how to dry run the code? Are you aware of how to dry run? How to dry run code? Dry run code means you see how it's working behind the scenes here. Okay, Fedos, thank you. No, okay, Sumit, no. Fine. Okay, no, sir. Okay, no. Okay, fine. How to dry run the code? First, let's see that. Okay, for that, we'll go with some code, maybe any code of our choice, even and odd. Okay, so we have this one. By seeing this code, we know, okay, this one will give us output as, okay, let's remove this also. These are not needed. So this one will give output as 1357 and 2468 10. So, but how computer is doing it? First, let's try to dry run this code and see. Dry run means we put breakpoints and we see that how computer is giving us the outputs. For example, here if I come and but put breakpoints here. Double clicking here means putting breakpoints. Okay. We put the breakpoints here, and then this and symbol, this is used for debugging. We are debugging this code. Right now, these buttons are inactive. Step over, step into. Now this will get active once we debug the code. So if I try to debug the code, see these buttons are active now. So I'm trying to debug the code. I'm trying to understand why and how this code is working. So if I try to step over, okay, we don't have the perspective. So even numbers are coming here. Only even numbers first it's printing. Then again here you see it's printing 0. It is going through every element, but it's printing 0. Again, if I do perspective, after this I'll do perspective as well and show you. So then again, one by one, this one is again checking, and now it should print 2. 1 is not there, 2 is there. 1 is printed here down. 2 is printed. Then again, it's checking every number, and then 4, 6, 8, 10. It's printing all the numbers one by one. Are you all aware of how to do dry run? Yes or no? Like we see the code, how it works behind the scene. Dry run the code. No, Spurthi, no. Okay, yes, Prasad, no. Okay, fine, fine. Okay, fine. Dry run is not okay, no. Okay, let's do it now and see. Okay, I'll take one more simple example. Since I can see more no than less yes. Yeah, okay, in VS Code also you can use debugger, but then there I'm not really sure how I can show you. Even if you want, you can search it online, maybe how you put breakpoints in VS Code. You have debugging option in VS Code as well. Fine. So now new class, okay, while demo debug. Fine. So we'll be using a while loop that we will be using for debugging. Okay, Pranav wants linear code. Fine, linear code I'll show you. Okay, Pranav, just 1 minute. First, let's do this and then we'll do this. Okay. So int speed is equals to 50. If I tell while speed is less than 60, speed plus equals to 4. And then I want to see the speed. What is the answer? So what will be the answer here? I believe similar code we have done it in the past. What will be the answer here? What will be the answer of this code, students? Perfect, 62. Good. What about others? 62. Yeah, correct. So this code is running 3 times. Correct. Very good, Shubham. So this code is running 3 times. If I run here, it shows 62. But if I put it inside this, now this one will show 3 results. 54, 58, and 62. See? Outside it's showing just 62. Now we are seeing how to dry run the code, how to debug the code and see. So for that, we want to see how this code is running. See, first I'll explain you in normal terms. We are telling speed is less than 60. Speed is 50. When speed is less than 60, while speed is less than 60, you add 4. So first it will add 50 plus 4 and it will make this 54. But it will not meet the condition. Then again, it will add 4, it will make 58. Again, it will not meet the condition. Then it will add 4, make it 62. It will meet the condition and here it will print 62. Is theoretically dry run understood? This code is running 3 times. Now let's try to see it practically. Okay. So for that, I have already put the breakpoints here. Here you can see double clicking means putting breakpoints. So now here we come and we try to debug it, use an and symbol here. And to show you much better, I'll go with Windows perspective, reset perspective. So see, here we have nothing here. If I step over, see my speed is 50 now. It has crossed line number 6. Speed is 50. Now it is checking while speed is less than 60. Yes, it is less than 60. So what I need to do is I need to add 4. So my answer should be 54. So now let's run it. See, now the speed has become 54. But still it is not getting printed here in the console. Why? Because I have said that while speed is less than 60, you keep on adding 4. And since this system.out.println is outside this curly brace, it will only get executed when this condition is satisfied. So again, this one is adding 4. And now here you see it will make it 58. See, it has made speed 58. Still, it will not print anything here. Why? Because it has not met the condition. Condition is the speed should be 62. Like it should be greater than 60. While it is less than 60, you cannot print. You need to add 4 all the time. If this was 10 and it was 60, it will run 10, 14, 18, 22, 26, 30, 34, 38, 42, 44, 42, 46, 50, 54, 58, 62. It will run that many times. So now here you see again. And now it has made 62. And now it's checking. If this condition is satisfied, it will not touch this condition. It will come out, and here at the bottom you will see the result. See, now it's telling I'm going to print out, and now it's printing out 62. The code is done. We are done with the code. Removing breakpoints, and now if I run this, see. So now is this understood? How to dry run the code? Anyone any doubts? How to dry run the code? Again, if you are using Eclipse, please try to dry run it once so you get a better idea. If you are using any another IDE, maybe even I need to go and check it because I'm not very well familiar with other IDEs. I do a lot of coding in Eclipse. But it's possible in all the IDEs. It's not like you can debug code only in one IDE. And now coming to one of the students. Here, this is your code. Linear search. See it, please. So basically what we are telling is, first we are going through a for loop and we are telling that I is equals to 0, I is less than array dot length I plus plus. If array of I is equals to target, return I, or else return -1. We have written the target already here. And then we are calling this method. Since it's static, we don't need to make an object. Array and target. And then if result is -1, you print element not found. If you find the result, tell element found and the index number. So dry run, everyone has understood how to dry run your code. You think how many times your code is going to run. That is called dry run. So now let's come to the main topic, time complexity. So we'll be using one solution, 3 different ways. Try to analyze the time complexity and you'll get a complete idea. First, if you have understood this part, then you will understand the time complexity much better. This part is understood. Anyone any doubts in this? Any doubts in while loop? Especially the debug part, dry run? Fine. Good, fair enough. If anyone is having any doubts, please ask right now. Fine. So now let's try to understand something much better, much more interesting. So I come here and I create a class. I'll tell it prime approach 1. I want to get prime numbers. We all know what are prime numbers. Okay, the number that is divisible by 1 and itself is called prime. Numbers that are divisible by 1 and itself are called prime. I'll be using 3 classes. Prime approach 1, prime approach 2, prime approach 3. We'll get all the same results but different ways. So here I come and tell system.out.println just prime numbers between 2 to 40R. So this one should print prime numbers between 2 to 40R, and then I'll write some logic and it should print my prime numbers. For now, it just says prime numbers between 2 to 40R. Okay. So I'll take a variable for loop int I is equals to 2, a for loop. I is less than equals to 40. I want 40 also to be included. So less than equals to I plus plus. I'm incrementing my I, and then I'm telling Boolean is prime. I'm giving a Boolean is prime variable true. By default, all are prime numbers. Then if I print all, it's going to print true, true, true. If it was in println statement, by default, all are prime numbers now. Now we'll take one more loop for int j is equals to 2. J is less than I, that means less than 40. J plus plus and if I modulus j, if I have this one, is answer 0, then you say is prime false, because if it is dividing, then it cannot be prime. If it is not dividing, then it is a prime number. And then you break the statement. So if I come and tell if is prime, if it's prime, you print. So now it should print all the prime numbers, that is 3, 7, 11, whatever are there, 13, and maybe like this. So these are our prime numbers. Is this code understood, students? What have I written? First, I am taking a loop that is going from 2 to 40. So let me explain you. First, is the answer understood? Then we'll see the working of this. And Nikore Sirinja says understood. What about others? First, what is the prime number? Are you aware of it? The number that is divisible by 1 and itself, that is a prime number. So here what is happening is, what is this code doing? Let me open Paint maybe and try to explain it to you. You will understand it much better. The reason why I'm asking for a Paint thing is because I want to explain you at a much better level. So basically, if I come here and tell, see, I'm taking numbers like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on until 40. I have taken the numbers. So is part 1 understood of the code? Then, of course, just pay attention here for next 10 minutes, and then I guess takes 10 to 15 minutes. So this is my one loop. So then I have taken again one more loop. So this one, again one more loop. I am writing it with other pen. What this one is checking is, it is checking each number. Is 2 divisible by 2? No, it is not. 3 divisible? No. It's checking all the numbers from 2 to 40 of my loop. Whichever number is divisible, like for example, 4 is divisible, so it is removing. 4 is not the answer. 6 is divisible, it is removing. 6 is not the answer. 8, it is again checking, it is not the answer. Again it is checking 9, yeah, 9 is divisible by 3, so it is not the answer. Again it is checking, yeah, 2 5s are 10, it is not the answer. 11 is not. 12 it is checking, okay, it is not the answer. 14 it is checking, it is not the answer. So it is going through each and every element, one by one. One by one, until 40 it is going. It is starting from 2 and going till 40. Is this understood, students? What is happening? I don't want to dry run and show you, but then this is happening. So I have here n numbers, for example. N numbers. N numbers means I have here 40 numbers. 2 to 39. So what it is doing is, it is checking all the numbers n time. It is checking all the numbers. So here we have n square, n raised to power 2. N square, I can tell. So the time complexity is O of n square, n raised to power 2. That is the time complexity, n raised to power 2. This is the worst case scenario. Worst case. Why worst case I am telling? Because after this you will get a better case and a best case. O of n square is there, n to the power of 2. because we are checking all the numbers two times. First, we are having 2 to 40, and then we are having one more loop, and that loop is going through all the elements in this array. And this is not the best code. This is, of course, giving you answer, but it is not the best code. Now let's go with some other approach. Prime approach 3. Now I know I've written 1 and then I'm writing 3. I have not written 2. I know it. We have this prime approach 1 that's giving us all the answers. We have prime approach 3. So in this, see, if I have to check 40, so I need to find a midpoint. So maybe 6 6 are 36 and 7 7s are 49. So my second approach, if I come here and show you, this is my first approach done. My second approach, I know 6 times 6 is equals to 36, and 7 times 7 is equals to 49. Okay, so somewhere in between, maybe 6.67. If I just go through 1 to 7, only these numbers, and if I check only these numbers, and whatever numbers, okay, from 2 to 7, I need to write here 2 to 7, and whatever numbers in this array I get as non-prime numbers, all the numbers that are divisible by this are automatically out of. Are you getting the question? Now, if I go till my target is 40, correct? So 40 is in range between 6 times 6 and 7 times 7. So I'll write the code. 6.67 is my midpoint, I can say. Wherein I don't need to check all the other numbers, like after 7, I don't need to check any number. From 8 till 40, I don't need to check any number. Why? Because they are already in this range. 1 to 7 is checked, all the numbers, okay, 2 to 7 is checked, and all the numbers in that range are divisible, the next number, so I don't need to check. Okay, let me show you the code way. You will understand it, right? So now I'm using another way. This is better way, and again, best way I'll show you after this. Int n is equals to 40, and then for loop I'll use for int I is equals to 2, I is less than equals to n, like 40, I plus plus, and here we can tell I plus, and here I'll make a method and I'm calling that method here prime of I. And now this one says prime of I is not defined, of course. So this is my main method. Here I'll define one more method, and that one is already there. So I'll just put a plus here concatenation. And now let me define the Boolean static Boolean prime. And this prime will take integer num. And here we are checking 40. So our target should be somewhere 6.67. 6.67. I have taken this number roughly, multiplied by 6.67. Is it coming or not? You can see. So we'll start from 2 and we'll tell while c times c, like 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. So it will do the total is less than equals to number. Our number is n, that will be 40. Int n, we have already passed here. That would be 40. And then if num mod c is equals to 0, you return false. And then you increase the c. And then you return true. So in this scenario, let's try to run this code and see. See, we get all the numbers here. 2 is a prime, 2, 3 is a prime, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime, 8 is not prime, 11 is prime. So we are going, 19 is prime. You can see we are getting all the answers. 37 is prime. Here also we are getting all the same numbers. Here we are going through all the numbers and we are telling you print true or false. But here you see we are going only till which number? If you see this prime approach to C times C is less than equals to N. So we are starting from 2. So 2 times 2 is less than our number, like 4 is less than yeah, of course. Then 3 times 3, 9 is less than 40, yes. 5 times 5, 25 is less than 40, yes. 6 times 6 is less than yes. 7 times 7, no, we are not going till 7 times 7. We are just going till 6 times 6. So here we are removing the numbers drastically. If you dry run this code, how many times is this code running? You see the number, dry run, if you see this number, if you see 40 into 40 times, it's running 1600 times. And then if you see this number, this is running just maybe 10 or 12 times. So if we see here, 40 is our target. So here we come and tell 2 into, so the divisibles here for 40 are divisibles of 40. Let's make it simple. So here you see, we get 40 is equals to 1 times 40 will be 40. Then you have 40 equals to 2 times 20, that is 40. Then 40 if you want, you have 4 times 10, that is equals to 40. You have 5 times 8, that is 40. And then of course, that's it. So if you see, we are seeing the divisibles. So for this one, you have time complexity of O n log n. Is equals to, yeah, 5 times it again, it's 10 times 4. It's 8 times 4, 5 times 8. Both are same, Abdul. So here you see, if you dry run this code, you have already reduced a lot of operations here. You are dealing C into C times C less than, so 2 into 2, that is 4, is less than 40. Yeah, 3 into 3 is 6. Sorry, 3 into 3 is 9. 4 into 4, 16. 5 into 5, 25. 6 into 6, 36. And 7 sevens are 49. So we are not going to check any number that is after 7. We are just checking 2, 3, 4, 5, and 6. 5 numbers we are checking with their multiples. Is this both code understood? This code and this code? We are getting the same results. Here if we run this, we are getting this prime numbers. But if you see, this one is checking all the numbers again and again. And this one is a smarter way. This one is checking less numbers. And still we are getting the same results. You can see the results are not different. Results are same. Whatever numbers are there, we are telling to return true, or else you return false if it is divisible. So 4 is divisible, so it's telling false. 12 is divisible, false. 14 is divisible, false. 20 is divisible, 21 is divisible, 22 is divisible. Whichever numbers are not divisible, it's telling true clearly. 31, 37. And here also you see, if we run it, we get 31, 37. So anyone any doubts in this too? Again, the best approach is coming after this, wherein we'll reduce a lot more time complexity in that. But first, these two approaches are understood or not understood. Again, after this, I'll share a PDF for this, wherein you can match this code along with the PDF. So you'll get a complete idea. Anyone any doubts in this? If you have any doubts, please ask me. Again, you need to do dry run so you get a clear idea, of course. Okay, thank you. So now we'll go with the best case scenario. That would be prime approach 2, new class. Wherein this would be the best in the 3. 1 is worst, 2 is better. Sorry, 3 is better, 2 will be the best. Fine. So, Sushmita ma'am. Hello, Sushmita ma'am.
Yeah.
Yeah, ma'am. So, ma'am, should we are the speaker joining?
Yes, sir. We can just for 10 minutes, we will just continue. Like after the guest, like speaker speak, you can.
Yeah, of course, no issues. So we'll go with the best approach after the speaker speaks. So we'll hold the session here. Okay, ma'am, over to you.
Yeah, thank you, sir. Nitya ma'am, over to you. You can take over.
Thank you, Shushmita. So, very good evening to one and all, those who are present here. I hope I'm audible to you all. If so, could you please give me a thumbs up? Or you can just use the chat and say, yes, I am audible. Okay, all right. Thank you so much. So I'm Nitya on behalf of XLR. Would like to take just 5 minutes of your time during this lecture of yours on ACE coding interviews, DSA mastery with Java. So, firstly, I would like to give my special thanks to our trainer for conducting such a structured, insightful session so far. And I get to see a lot of you are constantly responding to the trainer in the chat. So that's very nice of you. That shows that how well you are interactive, getting engaged in the session throughout, and helping yourself to constantly upskill on these lines. So not only this, but I've also seen some of you are constantly attending regularly. That is from the start till date, I get to see your attendance, that you are completely attending the session from the start till the end. So we are close to the completion of day 4, and it's though it is a small achievement, a part of the 15 days program, a small achievement, but I see that consistency is the best solution for the problem solving, and that truly builds your placement confidence as well. The one or those who I constantly see that you are responding in the chat, I'm really happy with it because you're able to clear your doubts and you're able to move forward. That is a first step towards you achieving to a level of bringing or getting noticed yourself and showcasing your talents, inner talents, and also you are climbing the stairs to achieve your goal. So the reason I have joined in for today's session is just not to interrupt your learning flow, but just to say or share something very, very important about what comes next immediately after your mastering this program, DSA Basics. So as you all know and you are aware, you get to see that currently in the market, DSA is one of the core pillars for cracking the coding interviews. So with that, we also need a lot of preparation in terms of your uh, career or your placement opportunities, or it could be in terms of that is the kind of interviews you would be facing gradually. That is once after your training program. So when it is about that, you need a structured preparation. You need to have a strong advanced problem solving skill, and of course you need to go through a multiple mock interviews and placement guidance, which are very, very equally important. So if you have a question in your mind, yes, I have mastered the basics in the DSA. Now, how do I get on to the next level, or who will guide me, or how do I be able to reach my dream job? So here we at XLR, we are going to train you on those aspects, on the career enablement with the right skills, the mentors who will be from the industry, and also in addition to give you that placement support, that is that which you think that it is missing. So here XLR is just not going to train you, but it will be a career launchpad wherein completely we are going to focus on your placement, just not by giving you training programs, but also giving you the placement support. So how is that which we are going to do that? I will take you through. So before that, let me give you a quick um, intro about XLR. XLR, a visionary leader that is founded by visionaries and established by alumni of IIM and ISB, with 5,000 plus recruitment partners and trusted 700 plus corporate clients, having a decade of excellence in training and placements, and being recognized as the leading global skilling partner, and 2,000 plus collaborations with academy institutions. In addition to it, we have strengthened our connect with the premier institutes like IIT Roorkee, IIT Mumbai, BITS Pilani, Hyderabad. So all of this makes XLR a national skilling network, and you will be getting strengthened. That is, you would be getting your learning from XLR from start till gaining the benefits of the placement opportunities through XLR. So we having our presence in cities like Hyderabad, Bangalore, Mumbai, Pune, Chennai, Noida, and learners across the world, where we have delivered online training close to 8 lakh plus students and professionals, having college partnerships through EDL and institutional outreach close to 2000 plus, and our strong associations with iHub Divya Sampark, APSSDC, APSHE, TAS, KMDC, IIT Madras, IIT Roorkee, BITS Pilani, Hyderabad, and having our courses approved on NASCOM and SWAYAM Plus platforms, with our associations with BFSI, ESSCI. So through all of this, we also have our decade of excellence in training the faculties close to 2 lakh plus, students 8 lakh plus, constantly delivering webinars close to 1,000 plus on all the technical, that is emerging technology front, with 30 plus technical courses, with 5,000 placement partners and 2,000 plus academy partners. So these are the proofs that our trainers have executed training at IIT Roorkee on program, that is on time series analysis and predictive analytics to research scholars, IIT Roorkee research scholars, students, and faculties. Similarly, at IIT Bombay, faculty development program on full stack development. BITS Pilani, Hyderabad, where we have delivered training program for students on Power BI and machine learning. Now, you would also be given the same level of training which the IIT Roorkee scholars, research scholars, and faculties have experienced with industry expertise, wherein we offer training programs with placement assistance, which is on data science, data analyst, business analyst, artificial intelligence, generative AI, agentic AI, full stack development, Java, core Python, Tableau, Power BI. So it is like multiple tracks which will be available for the learner. And how do we do all this? Is we have a complete online classroom training is also available, and live online training is also available with a top-notch faculty. And all of these classes would be live, expert-led classes on industry updated curriculum. So we would have the the entire curriculum curated based on the industry experts' input, with assignments, real world projects, with dedicated support from the mentors, with lot of assessments and evaluation to make you prepared for the toughness in the interviews, with a certification. That is, you would hold a certificate post completion of this training program. In addition to it, you would have the clear structuring of your resumes. Say, for example, if you have done a project, so there would be multiple projects which you would have done during your engineering, but you really don't know for which job position you need to position your projects, which is the one which is of high priority, which is that what, how much should I elaborate on the project, or what is that which is the HR or the interviewer would be looking for in the resume. So all of these would be discussed with you, and a detailed structure of your resume will be built. Similarly, on the LinkedIn, and there would be career opportunities given by the placement officers of XLR, wherein they would bring in the hiring partners, and you will have on campus drive, direct interview calls, all of these. So, thus, we make the learner job ready through our training program. So, how does the placement process look like? Wherein, to start with, once after the completion of your training program at XLR, we would be handing over the set of students to the placement officers, where they would start working on your profile, LinkedIn, project presentation, and there would be multiple skill evaluations done with mock interviews, and shortlist you for the respective hiring partners. Once the calls and the selections happen, you would be receiving your job offers. In case if there is some wherein you are not being chosen by the placement, the hiring partner, again, the entire cycle would be done, wherein we would see that what are the gaps, why were you rejected. Okay, if it is technically you were good, but you had to improvise on your aptitude learning, verbal reasoning. Again, the trainers would start working on it, and then will hand over you to the placement officers. So this is the continuous process of the placement process. And okay, all this is happening, but I am not kept in loop. I, as a learner, I am not kept in loop. So that is also made possible here at XLR, wherein you will be that is be able to view the entire placement process through this lineup X. What is this? Is from the time you have completed your training and you are being getting into the placement process, you would be able to see, visualize that what are the number of job openings which are there currently there. So then you get an understanding. Okay, there are 10 opportunities. For these 10 opportunities, will I be the right one? Or what are the areas where I will have to upskill myself? So that's how you would be able to visualize that what are the live openings and track your stages of your interview. Say, for example, Nitya, as in I have completed my training program at XLR and now I am entering the placement process. I finished with my technical or my written test at some X company. Now I need to find out what will be the next stage of mine. Then there will be a notification. Okay, there is a group discussion which will be followed by the written test. Then there will be another technical interview, face-to-face interview. So these stages of interview will also be can be tracked in this tool. And those students who are shortlisted, those updates or the notification also will come to you. So it is more or less, it's like handy for you to know that, okay, I have now entered the placement process. Now, where exactly I stand to reach my destination. That is my job offer. Where exactly do I there? Where am I there? Suppose if there are some gaps, what are the areas of improvement? Whom should I connect? So all of these information you would be able to visualize in the lineup X, and your placement officers and your coordinators at XLR will be able to guide you. So as of now, we have 11,000 plus openings readily available with 5,000 plus active hiring clients and 100 plus learners are aligned for the interview process currently. So these are some placement records of the student for your reference. And as I said, you would also be like, say, for example, you think that, okay, now I think that somewhere I have undergone this XLR's training program. Now I need to advance my skills and also look for career opportunities through XLR. But where and how I can help you out. Before which, to get a proper understanding of where exactly you stand, we have our counselors and there would be free counseling done by our counselors, and you can walk into any of our that is locations at Hyderabad, Bangalore, or Mumbai, Pune, all of these locations, and you can get the complete guidance from the counselors of ours. Okay. And once you are, you think that, okay, I need to upskill myself on these areas, we provide you with classroom training, we provide you with the online training program. So it is up to you to choose what kind of or mode of training you would want to based on your feasibility. And for the right like which is the course which I have to upskill on, we have our counselors who will be able to guide you through. Now, let me give you a short view of our classrooms. Let me play this for you. You may not have the audio, but you can just visualize the kind of classrooms. Okay. So you've just seen the classrooms, how our classrooms look like. Okay. Now, if you think that, yes, I would want to experience the kind of training program XLR gives and would want to check out on my career path, you can either walk into any of our offices, which I would be sharing you the details in the chat. And as well, you can scan here the QR code, fill in the required information which is being given there, and we will be connecting with you. We will reach out to you over phone, and our career counselors will guide you what exactly you will have to do. So I'll hold this for some time, the screen for some time. You can quickly take your phone and scan the QR code, quickly fill in the details. And parallelly, I will also share the link in the chat so that those who are not having or who have logged in the session through the mobile, maybe a little later, you can copy this link and scan the QR code. Either is possible. So through our counselors, you would be getting free counseling and a complete roadmap guidance, and you would be able to like track your selection process from the start till the end. And as you had seen, IIT Roorkee, BITS Pilani, Hyderabad, you will also be experiencing a professional environment which is completely designed for you to experience like a corporate training kind, because we are not here to groom you uh, in a classroom session which is only equipped for the level of a college, but it is beyond it, where we would want to take you to the level of the corporate. So all of our, we prepare you for a workplace environment. So if you think that yes, without any delay, you need to book your free career roadmap session, this would be the first step. Just pick up your phone and scan the QR code, and you will receive a call from our counselors by tomorrow. I would definitely say that one decision of yours which you would do today, immediately after your graduation, yes, there would be a lot more career opportunities through XLR coming in at your doorstep for you. If anybody has any questions, you can post it in the chat. And parallelly, I would request Shushmita to share the link in the chat as well, so that the students can copy it and then they can scan it later.
Yeah, sure.
Okay, so I believe this, if there is somebody else using, please let me know. If not, I would end up here and I would hand over the session to our trainer.
Students, if you have any doubts, please put it in the chat box.
So those who have questioned me, is this free or paid? The programs which I had showcased here will be paid programs. So these would be the paid programs. Yes, the counseling will be free. Regarding the course fee and all, our counselors will connect with you. All that you have to do is fill the form which I had requested for. All right. Thank you all.
Yeah, students, you can take 2 minutes of time to fill up the form. And then, of course, in next 2 minutes, we'll start with the prime approach to the best case. And then we'll see the time complexity there. Okay, it's 8:22. By 8:25, we'll start with that. If you have any doubts, by the meantime, you can scan it, fill up the form. When you get the call, you can, of course, form. Okay, I guess, ma'am, can we get the scanner again? Here is the QR scanner. Please scan it up and whatever details are there, fill it up. You'll get the call from the counselor, and whatever doubts you have, you can ask the counselor there. The counselor would be the right person. Me or Nitya ma'am, we don't have too much details about this program. She is expert in her role. I am good at my role. So when the counselor calls you for free career guidance, you can ask whatever doubts you have.
Dear students, the form link is on chat. I request please fill this form, and this is not any attendance link. So I request not to ask like anything about the attendance. It is a registration form where if you have filled this form, our counselor will connect with you and they'll let you know about the programs or whatever the guidance which we are giving. So I request please fill this form and as please be noted, this is not the attendance link. This is a guidance form.
All right. Thank you very much, team. So I would like to hand over the session to the trainer. Mr. Mohsin, over to you.
Thank you, ma'am. Thank you very much. So now let's go with our coding part. And let's try to see the best approach. So what is the best approach here? First, we'll code it, then we'll understand. Sieve of ethnosis is the guy who invented this technique, which will reduce your time to a much greater extent. It will be O log n. So here we come and we have a main method here and we tell int n is equals to 40. Of course, we are going till 40 only, because we are trying to understand the time and space complexity. Later on, we'll do all the coding part. On the basis of this, we'll get a clear idea. So here we come and we tell Boolean array of prime is equals to new Boolean n plus 1. Now, Boolean array has a default value of false. By default, everything is false in Boolean array. So we are going to use sieve methods because it's sieve method. I'll be making this method which takes a number and it will check for primes. So that's it. And now here we will have a static method that does not return anything, but it's a sieve method. So this sieve here means this is a person who invented this. So it takes an integer of numbers and a Boolean array of prime. So we have called it already on top. So here we will be using a for loop, but we'll be using smartly. Why? Because if you see, I'll come here and tell for int I is equals to 2, I times I multiplied by I is less than equals to number. At that time you increment the I. So 2 times 2, 3 times 3, 4 times 4 in that way. If not prime, if it's not prime, I. Again you come here and tell for int j also will start with I times 2. So 2 times 2, 3 times 2, 4 times 2, so on. J is less than equals to num. And then here we come, j is equals to j plus I. So we'll increment j. So here we have, and we'll tell prime of j is equals to 2. So now, again after this loop, yeah, here it's no. After this if condition, we'll put one more loop. And once I write this code, I'll explain you all what we are doing for int k is equals to 2. We initialize with k is less than num, okay? And we do k plus plus. So we have used 3 loops for sure. If not prime, k. If it's not prime, oops, k. And I guess it should be a round bracket closing here. And this curly brace, yeah, there was a small syntax error. Okay. So now here, this is our best use case. And then if I try to run this one, 1 minute. Okay, I did something wrong. We are getting just 2 and 3. K is equals to 2, k is less than num, k plus plus. Okay, 1 minute. What wrong did I do? Let me check. N is equals to 40, Boolean prime, new Boolean, n plus 1 prime, sieve n prime, okay. For int num Boolean, I is equals to 2, I times a less than equals to n, I plus plus, if not prime I. J is equals to I times 2, j is less than equals to m, j is equals to j plus I, okay. It should be j plus I. We are going just till 1. So see here what happens is, we are again getting the same answers. But if you dry run this code, these are again our prime numbers. Now, can anyone explain to me why am I calling this one the best use case? First and third one, they are understood. Now, can somebody explain me what has happened in the second one, prime approach? See, we already saw on paint our first use case, our second use case. So now let's go with our third use case and see. So here what we are doing is, again, we are going from 2, 3, 4, 5, 6. Only till here we are going. Okay. Numbers after this 7, 8, 9, we are just ignoring them because we have already seen that in second use case that this is the barrier break wall. Until here, yeah, Abdul, of course. I'll put it on GitHub, baby. Okay. So we have seen this 2. 2 is not a prime number, correct? So 2 is not a prime number. So we circle 2. It is not. So then what we do is 3, of course. Is 3 divisible by 2? No. 3 is also not a prime number. 4, we are not checking 4 here because 2 already is dividing 4. 6 is also divided automatically. 8 is also divided. 10 is also divided. When we went with the 3, all the divisibles of 3, of course, are divided automatically. Then we go with the 5. Okay, 5 is not divisible. So whatever divisibles are of 5, they'll get strike off automatically. So here we are just checking 2, 3, and 5. That's it. Since 4 and 6 are also divisible already, in this best case, we are not even checking this numbers also. All. In this also, we are just checking 3. Why? Because 4 automatically got divided, 6 automatically got divided when we were checking 2 and 3. Is this understood? Is this clear or not clear? If you do a dry run, you'll get an idea. First, you need to understand the worst case scenario. Then you need to understand the better case and then the best case scenario. The prime approach 2 is the best case. Why? Because in that we are not even checking the entire code. Right. Understood or not understood? Jatush has said no. So there is a doubt, or like you have understood, there is no doubt. If it's clear, tell clear in the chat box. If it's not clear, tell not clear. Not understood. Okay, Jatush, no issues. Fine. Okay. Thanks for asking. So first, okay, let's see the scenarios. See, this was our first approach. In this approach, what we did is, okay, fine, file, new. In our first approach, what we did was, we made an all the numbers we did 2, 3, 4, 5, 6, 7, 8, 9, 10, and we went on and we made one more loop wherein this was maybe our I and we had J. So J was checking everything. It was checking 2 also, 3 also, 4 also, 5 also, 6 also, 7 also, and so on. This was our first case. His first case understood. Jatush? Fine, okay. Is case 1 understood? Is approach 1 clear? Approach 1 is clear or not? Okay. Fine. So approach 1 is clear. Very good. So now we went with approach 3, wherein we took a point. So we said that 2, 3, 4, 5, 6, okay, and then 7, 8, 9, these numbers were there. So in our second approach, sorry, in our third approach, what we did is we checked through 2, whatever numbers were divisible by 2. For example, 4 was divisible, 6 was divisible, 8 was divisible. Again, we came here, we went with 3. So in 3, 6 was again we divided, again with 9 was divisible. Again 4 we went, again we checked 4 here. Already it was cut, but still we checked 4 here in our third approach. So again we cut this one, again we cut this one. Again for 5 we went, we checked, okay, fine. Again for 6 we checked here again. So 6 was removed, then 12 was removed, again it was removed. But we checked all these numbers in our third approach. Is third approach clear? Third approach is clear. Yes. So now we went to the best use case. So the best case was our second approach. And in second approach, what we did is we had already these numbers only 2, 3, 4, 5, 6, our breakpoint, correct? But here what we did is we targeted to 4 is removed. 4 is not there in our list. 6 is removed. It's not there in our list. So 3 we checked. Okay. Then we just went with the 5. 5 also we checked. Then we moved only 3 numbers we checked and we got the answer. Second approach was the best approach. Why? Because in this we checked only 2 numbers. Sorry, 3 numbers and we got the answer. Now let me share you the approach wise thing. So you will get a clear idea. So if you see here. So what is a prime number? A prime number is a number greater than 1 and that has exactly two devices. Two devices, one and itself. Brute force approach, worst case. So see, in our approach 1, this was the scenario. Idea for every number check divisibility by all smaller numbers. Nested loops are used. Too many unnecessary checks. Works but inefficient. So this one, if you want, you can take a photocopy also of that. So our approach 1 was this one. Of course, I'll share the documents also. Don't worry. But I'll share it to the madam. Our third approach was square root optimization. It was better. Check divisibility only till root of n. So basically we went till 6.67. Based on mathematical observation, reduced number of checks, common interview solution. Time complexity is O n square of n and space complexity O of 1. Now this one was our best one. Sieve of ethnosis for use for range. Eliminates non-prime numbers by marking multiples, uses Boolean array, cancels multiple instead of checking primes. Most efficient for finding primes in a range. We are finding prime in a range of 2 to 40. Complexity is O n log n. O n log n and space complexity is O of n. Space is linear. Because here we are compromising with the space. Here space is best, but then we always compromise space when it comes to time. Like if we are reducing the time, space can be compromised. Here in this, you see space complexity was linear. O of 1 best space complexity, but here space is a bit more, but time is best. If you have a choice to compromise on space and time, you will always compromise on space, but you will have time as your constraint. Again, this note will be shared with ma'am and ma'am can share it with you. If you are not getting it, please tell me because I'm sharing it with Sushmita ma'am and I'm pretty sure she's sharing it on LMS. Again, let me repeat you will not get it on personal email IDs, you will get it on LMS. So is this understood? Anyone, any doubts, students? Approach 1, approach 3, approach 2. We went with the approach 2 last. That was the best one. If there are doubts, please feel free to ask. Sure, Jatush. So Jatush wants to see the code approach for 2. Yes, sir. Why not? So here we are into code of approach 2. It is taking more space for sure. That's why the space complexity is more. So first we are telling I is equals to 2. I times I, like 2 times 2 is less than equals to number. 2 times 2, 3 times 3, 4 times 4. And then we are taking one more loop j, I times 2. J is less than equals to num. J is equals to j plus I. We are incrementing it by 1. And then we are using again a k variable. So here we are using extra space, that is for sure. But then of course, it's eliminating time to a lot. Okay, so now should we move to more question, or you feel like, okay, this is getting too much? Should we solve one or two more questions or go with some theory? Continue, sure, why not? Okay, what is sieve, sir? Okay, sieve of, okay. Theory, okay, somebody is telling theory. Yes, sir. Okay, fine. Sieve, what is sieve? Okay, let me show you. Theory, okay, we'll go with the theory, don't worry. Okay, don't worry. So first, let's see what is sieve. Sieve of the sieve of hypothesis is an ancient, highly efficient algorithm for finding all prime numbers. So it is basically created by one guy. Like we have Aryabhatta, there was someone called sieve also. Now, वो कौन से जमाने में था? Like it was in which duration? I also don't know. Somewhere in 3rd century, Arthrosis was his name. So we honor that person by telling sieve. Okay, you got an idea what is sieve now? Somebody was asking me in the chat box what is sieve. So just to honor that person, we tell, like we have Nikola Tesla, who was of the idea that mobile phones will come. So Tesla cars are there. So in the same way, there was someone called Sieve. That was much before 3rd century BC, before Christ. Now we are into AD, and that to 2026. Why we used in code? Okay, sir. It's Shekhar. Shekhar, sir, if you see, the sieve is an ancient, highly efficient algorithm for finding all prime numbers up to a specified n range by iteratively making. So just to honor, we tell it sieve. You can write your name also, Shekhar. That is fine. You can use your name also, but of course, it's a standard practice that we use sieve's name. It's not compulsory that you should use sieve only. We can use any name. It is completely fine. For example, why we always take I? Because we initialize it with I only. 99% of the times you will see in for loop I only. Although you can write anything from A to Z, but we'll start mostly with the I only. For Boolean, we'll always write is prime, is available, like that things. So now let's go with a bit of theory and then we'll close it. So here we come, DSA notes, DSA all pattern questions. Okay, these are, again, I'll share this one also with you, not to worry. So again, these are pseudocodes, sliding window and all. We'll cover it later on for sure. But right now, let me see what can we do. Okay, DSA revision guide also. No, but then of course we'll go with this one only today. Of course, I know most of you said theory. That's the reason. Fine. So binary search, what it is. Sorting algorithm, sorting. There are many types of sort also to rearrange elements in a list or an array. So you have bubble sort. It's a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, swap them. If they are in the wrong order, this process is repeated until the list is sorted. So bubble sort is there. See, you see this example. You have 4, 2, 4, 6, 3, 1. So each element will sort itself. And then of course, you will get the sorted version. You can sort it ascending way or descending way. Bubble sort is a simply sorting algorithm that repeatedly steps through the sort thing. So basically swapping is there. You swap from left to right, left to right. So here you see you get 2, 3, 4. So the last answer that you get is 1, 2, 2, 3, 4, 4, 6. First you have an unsorted array, maybe 4, 2, 4, 6, 3, 1. So the last one is 1, 2, 2, 3, 4, 4, 6. Selection sort is there. It's a straightforward sorting algorithm that repeatedly selects the minimum element from the unsorted portion, of course, of the list and swaps it with the first unsorted element. This process is repeated until the entire list is sorted. So we find the minimum element and then we sort it. Selection sort is there. Insertion sort is there when you insert it. Again, when we'll be doing questions, of course, you will get all the idea. As and when today is just the 4th day, we have total 11 more days. Quick sort is there, wherein you sort things by a partition. Heap is there. Heap basically is a comparison based sorting algorithm that uses a binary heap structure to arrange elements in order. It first builds a max heap from the list. So basically you have a parent and then you have child. Nodes are there. Root is there. You increment. Counting sort is there. Counting sort is a non-comparison based sorting algorithm that works by counting the occurrence of each unique element. So basically you count it and then you heapify your search there. A lot more things are there. Of course, stacks are there. Stacks basically uses LIFO, last in, first out. And then you have pop and push, 2 methods only. Again, which one to use where? Now beginners have a lot of confusion. So for that also we have a guide. Which data structure you should use when? That is the doubt. And to solve that doubt, I guess. 1 minute. No, this is not the one. 1 minute. Which data structure you should use where? If you have that doubt, so if you see this clearly, so you have a sliding window. You go with the binary search, greedy algorithm is there. Greedy will take everything. Dynamic programming is there. When you have overlapping sub problems, stack is there, heap is there, tree traversal is there. Again, if you see here, real world uses. Arrays are used in spreadsheet cells, image pixels, linked lists are used in music playlist. When we have next and previous, stacks are used when you do undo and redo call stack. Queue is used when printing. Hash table is important. API caching. Graph is used for social connections, map routing. So all these things, once you start doing coding, you get everything. Again, this is your time and space complexity. The other day when we were talking about O of 1 is the best. Here you can see input size and your time. Anywhere between O and log n, you are safe. O log n, O and log n. Until here, it's okay. O of 1 is the best one because it's the constant one. The moment when we were doing the fast total of 1000, 500 was the answer. At that time, you know, we did O of n and O of 1. So O of 1 was taking only 3 steps. So these are all things. Constant time, linear time. Again, this all notes, believe me, I have nothing to keep with me. What will I do by keeping it with myself? I'll share everything with ma'am and ma'am will give it on LMS, I'm pretty sure. Because knowledge, of course, when you spread it, it increases. I have nothing to keep with me. I personally believe that if I share it with you, it's going to be more helpful for you. So now my target is we should complete these questions. Hopefully from tomorrow we'll start with this. How many of you are already there on lead code? Should we take lead code questions or should we make our own questions? Should we take lead code questions? Lead code. Okay, Jatush said lead code. I'll share. Okay, anything is fine. Okay, let's do it at a not neutral level because most of you are telling that do it at a neutral level. Lead code. Okay, let me show you from lead code also point of view. Like I'll show you the pseudo code and maybe help you with the coding pattern. I do have, I guess, lead code now. 1 minute. DSA notes. 1 minute. Yeah, DSA question and answers, they are there. So these are 50 top DSA questions along with the solution. Of course, so these are lead code questions only. With two sum is there, brute force approach, using hash map, maximum subarray, move zeros, optimize one, rotate array, trapping rainwater question. Then string questions are there, of course. I guess string we have done already few, but then is anagram or not? We have already done it. Count characters, longest palindromic substring, group anagrams, longest common prefix, Roman to integers, linked list questions. Tomorrow we'll go with linked list maybe. Tree, graph, all these things are there. I'll share everything with ma'am Jatush. I know, of course, like you need this. I'll share it with ma'am and ma'am will upload it on this one. Lead code, lead code I'm telling you, this one. LMS, stack and queue. We have just taken 5 questions of each. Again, with practice only, we'll come to know the best thing: sliding window, maximum, minimum, climbing stairs, house robber, coin change problem, greedy algorithm, gas station, backtracking. So basically, you go back to the solution from one to another. You have list of integers. So basically, if you are not aware with collection framework, please, you have time, go through. All these notes that I'm showing you, they will be shared on LMS. Okay. I'll be sharing it with ma'am, and then ma'am will be sharing it on LMS. Now again, these are some a bit design patterns. These are a bit hard questions. So first, I would recommend, yeah, recursion. Basically, Shikhar, it's you go again and again until you find the answer. You try to repeat the thing. Again, we'll do with recursion also. Don't worry. Okay. Recursion is not very hard, but then of course we'll see recursion. Recursion means basically we go again and again to the same solution until we get the answer. So these are all the notes here. Again, 2 pointers. So here also you have. So tomorrow maybe we'll go with linear search and binary search questions, remove duplicates and all. And yeah, hopefully that's it. These notes will be shared with you for sure. I'll share it with ma'am. And if you have any doubts, you can ask me. Or else we can. And because if you are doing it, these questions are there. And again, you see, you have explanations as well for this. Like there's a lot of material, to be honest. No, there are no assignments for tomorrow, Abdul. Thank you, Ritika. See, even I do make mistakes during times of interview. Sometimes I do silly mistakes. I even forget semicolon, and it's the human nature. Like sometimes we are so much into one thing that we forget other thing, and it's okay. No need to worry about it. Just try to give your best in interviews. That's it. Nothing else. Okay, so that's it for today. If anyone is having any doubts, you can ask me, or else we can wind up today's session. and we'll see tomorrow. We'll go with, of course, sorting and linear search and binary search. So anyone any doubts? If you have doubts, please put it in the chat box. Okay, then Sushmita ma'am, can we end the session?
Yeah, yes, sir. We can wind up. Thank
Sure.
you.
Thank you, everyone.
Yeah, thank you all. Good night.
Good night.